developer advocate at JFrog. She's a mom. She's a Docker captain, a Java champion, and co-author of an upcoming book, DevOps Tools for Java Developers. Melissa's a longtime developer turned international speaker who will be sharing today on the Docker and Container Ecosystem 101, a presentation that she actually shared at DockerCon this year. So without any further ado, we want to welcome Melissa.
Hey, everyone. Hey, I'm super excited to be here. Really happy to be, it is, I think it's 12.5-hour difference or something like that. It's actually 9:45 here right now. I'm located in Denver, Colorado. It's been really hot here the last few days. But other than that, nothing to complain about. I am excited to talk to you about containers today, the Docker and container ecosystem to be specific. We're going to have a new batch of developers new to containers and to Docker every year. And my personal introduction was sink or swim. I found myself wading through a bunch of new terminology I didn't understand, and I discovered quite a few stumbling blocks that slowed me down, not to mention suffering some of the consequences of trial and error. So my goal for you for this talk, the first one of today, is to have a good foundation before you jump into the deep end of containers. We've got a lot of container talks tonight, and sometimes we forget that there may be some folks in our audience that are brand new to this and need a little background. I could have really used a session like this to quickly get me up to speed on understanding the terminology, the different components, and the big picture, and clear up any silly misunderstandings of overloaded terms like container, or do we actually store containers in container registries, that kind of thing. This is our agenda today. As Ari said, I did present this talk at DockerCon, and it was one of the introductory talks, so I hope that you can get a lot out of this today. Right now, I'll just, Ari introduced me already, so I'm going to briefly go through a slide there so you have my Twitter handle and all of that business. And then we'll move on to a discussion of why one might want to get comfortable with containers right now. The history lesson is the heaviest portion of this talk, so make sure you're in a comfortable spot. Get comfortable in your chair where you can absorb this info because it's going to come at you pretty fast. I'll give a brief explanation of the Docker ecosystem, some of this 101 terminology around containers, and then I'll finish off with a few resources for you to go and learn more. Ari already introduced me. Thank you very much for that beautiful background. I have been in the industry for over 20 years, have been a developer at various levels, and a year and a half ago joined JFrog as a developer advocate. I am a Java champion and a Docker captain, and you can find me at on Twitter at Melissa J. McKay. All right, so let's get started. My introduction to Docker was by way of a project that was developed by a third-party contractor. So in my case, this wasn't a decision made by our team at the time. The first thing that I saw when I was ramping myself up on the code base were those Docker commands in the README file and a file named Dockerfile in the root of the project. I'm always up for learning something new, so I was intrigued. What is this Docker thing? This particular project that introduced me to Docker was already designed, code was already written and functional. So in this case, the best thing for me to do was just to dive in and figure out how to set it up, how to build it, and deploy it as it was. This strategy has always worked pretty well for me when ramping up on any project, especially when it involves a new tech stack or framework. Follow those instructions the best you can if you have them. We were lucky in this case to get it up and running. Make note of any difficulties or questions that come up, adjust the instructions if necessary, and then go back through again to understand how all of those pieces fit together. This is something that you would do repeatedly at the beginning of a project. Right away, I had so many questions, like these questions here, but there was nothing initially stopping me from moving forward. I learned best by doing, so my first step was to download Docker Desktop to try this thing out. Before we get into those Docker details specifically, let's ask the most important question: why would we or should we use containers? I don't know why Docker was chosen for the project that I was tackling at the time. I was not involved in those initial discussions, but as I worked with it and setting up our development environments and our CI/CD pipelines, I saw several advantages. If you're doing the same and you're thinking of wrapping your applications in containers and going cloud native, just take a moment to consider the problem specific to your project that you'd like to solve. Put these down in writing somewhere. I see so much documentation out there that goes into depth on how to do something without explaining anywhere why. So let's go through this list. The first one here is kind of a joke. Really? You're using Java 11. Well, Java 11 was released in September of 2019. Java 16 just came out recently, but I know so many projects that are still back on Java 8 for various reasons. I know it's frustrating to deploy a nice new Java 11 application to a prod machine that only has Java 8 installed. That's just one example of, a language-specific problem. Obviously, applications that are containerized are not all going to be in Java. I'm just pulling from my experience and my background here. The second item here, I love my MacBook. My workstation is my MacBook. I was introduced to Mac, I don't know, maybe the third position I was in or the third team I was on, and I haven't gone back since. I love it. But how many of you have worked in code that has a bunch of if statements in it around what OS you might have? I had coworkers that were running on Windows. I'm sure there are some legitimate reasons for this, but I'm remembering scars from the browser wars, the web browser wars. But I actually had a situation once where unit tests I ran failed because I was on a Mac instead of Windows. There were some other issues there, multiple problems there to address. One was how it was dealing with the file system. But it is nice to be able to have the option to run unit tests in a container without having to worry about every possible OS. The third item here, there's a bug in production. The first thing you do as a developer is to reproduce the problem. But that's difficult when you're already developing the latest and greatest and you've made changes to your environment that are not backward compatible. Consistency and build reproducibility is key when you're chasing those bugs. Number 4, it works on my machine, only on my machine. That's related to number 2. Again, consistency in software versions and libraries will make your life so much less complicated. Number 5, we just hired 3 new developers. This has happened various times in my career where a new team is started up or new members of the team have joined. That consistency that you get from step 4 will make onboarding those team members so much faster. So number 6. My service is super popular. This is a good problem to have. You've put your service out there in the cloud and now it's getting hit with a ton of traffic. One of the biggest reasons for moving to modularity and to containers is utilizing the strategies of cloud native deployments to quickly scale that application as you need as load increases. Now you might be asking right now, don't virtual machines solve this problem for us? They have isolated environments. It should be, just fine. But the problem with VMs have their advantages, but they are not as lightweight as containers. VMs contain an entire copy of the OS. So it's not as lightweight as a container, which actually shares the OS of its host with other containers. Even if you're not using containers in production today, there are other scenarios worth considering the use of containers in your development pipeline. Those dev environments. Don't suffer from the disappointment of spending that entire day debugging a problem that you find out happens only on your machine. The test environments. Having that ability to easily launch other external services like databases, that type of thing. Being able to improve your test automation, that's an advantage. And then, of course, production. You may have a problem with securing dedicated resources. I know that I was in a situation where getting a new server set up in production involved quite a few IT tickets and a lot of time. You don't have to wait for custom provisioning or worry as much about inconsistency when you're able to deploy with containers. Now I want to get into that history that I referred to earlier. It's really easy to skip this part when you're eager to get started, but I recommend going through this exercise with any new framework or technology that you want to start using. This will be quite a bit of info, but bear with me because it's worth it. Understanding how we got here and where the tool you're about to commit to for your project, where it came from, can help you avoid some nasty pitfalls and help you use that tool in the most effective way. You know that popular cognitive bias, if all you have is a hammer, everything looks like a nail? This is also applicable here. Containers are useful, but aren't intended to solve everything, yet anyway. All right, in the 1960s and 70s, computing resources were a lot more limited than today. Computers were commonly dedicated for long periods of time to a single task for a single user. Of course, these limitations resulted in plenty of bottlenecks and just general inefficiency. Efforts were started to develop a method of sharing resources without getting in each other's way or having one person inadvertently cause the entire system to crash for all of its users. Both hardware and software that advanced virtualization technology started to trickle in. One development in software was Chroot, which is where we'll begin. In 1979, during the development of the 7th edition of Unix, Chroot was developed and then later added to the Berkeley software distribution, BSD, in 1982. This system command allowed for the ability to change the apparent root directory of a process and its children, which results in a limited view of the file system in order to provide an environment for testing a different distribution, for example. Chroot was a move in the direction of providing the isolation required from us today, and several years later, in 2000, FreeBSD expanded that concept and introduced the more sophisticated jail command and utility in FreeBSD 4.0 release. Its features which were later improved in 5.1 and the 7.2 releases, those features helped to further isolate file systems, users, and networks, and also included the ability to assign an IP address to each jail. In 2004, Solaris containers and zones brought us ahead even further by giving an application full user process and file system space and access to system hardware. Google jumped in with their process containers in 2006. Those were later renamed to C groups, which centered around isolating and limiting the resource usage of a process. In 2008, C groups were merged into the Linux kernel, which along with Linux namespaces led to IBM's development of Linux containers, LXC. You may have heard of those. Now things get even more interesting. Docker was open sourced in 2013. And that same year, Google open sourced their Let Me Contain That For You project, which provided applications the ability to create and manage their own subcontainers. And from here, we saw the use of containers explode, Docker containers specifically. Initially, Docker used LXC as its default execution environment, but in 2014, Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer, which is a native solution written in Go. That was something new that I learned. I didn't realize that Docker was written in Go. Soon after, the Let Me Contain That For You project ceased active development, with the intention of joining forces and migrating the core concepts of that project into Docker's libcontainer. A lot more stuff happened, but before we leave this, I want to point out something specific that concerns Java applications. In July of 2011, Java 7 was released, and Java 8 was released in March of 2014. Given the development going on in containerization at the same time, it shouldn't come as a huge surprise that older versions of Java are not fully container aware, except it is a surprise. If you don't know this and you wrap your Java 8 application only to suffer from out-of-memory killer activity. The reason for this is that the mechanisms the JVM used in these older versions to retrieve the resources available come from the actual host machine and not the C group limits that you would expect. Although possible with later Java 8 updates, I believe it's 121, is the best you can get for Java 8. It's recommended to get to Java 11 in order to get that version that is fully container aware. All right, there's a lot more that happened during this period of time. I'm intentionally going to skip over some of those details in order to get to a specific event in 2015. This event is really important to know about because it'll give you some insight into some of the activity and motivations behind shifts in the market, especially concerning Docker. On June 22nd, 2015, the establishment of the Open Container Initiative, OCI, was announced. This is an organization under the Linux Foundation with the goal of creating open standards for container runtimes and image specification. Docker is a heavy contributor, but in their announcement of this new organization, it was said that over 20 organizations were involved in this. I would read that list to you just so that you can fully comprehend how big of a deal that was. These are a lot of companies, a lot of organizations involved. Containerization has evolved to such an extent that this number of organizations wanted to work towards some common ground for the benefit of all. The OCI accomplished some big things. They had in June 2015, when they were established, they had the OCI runtime specification, the OCI image specification, the OCI distribution specification. And in July 2017, the runtime and the image specs were released as version 1.0. On May 4th, 2021, the distribution spec was released, again, version 1.0. Docker had a lot to do with these specifications, and I'll talk to you more about what those contributions were in a minute. One month after the OCI was established, the Cloud Native Computing Foundation, or CNCF, was established. The CNCF does a lot. There's a ton of projects there that are either incubating or graduated under its umbrella. There are a few activities there that you need to know about for our purposes. Along with the developments in the container ecosystem, orchestration was also in rapid development. Orchestration frameworks like Kubernetes took on the responsibilities of the coordination, configuration, and management of containers in deployment environments. Kubernetes version 1.0 was released at the same time the CNCF was announced. Kubernetes was contributed by Google and was the first project that was brought into the CNCF. Right on the heels of that first release, version 1.5 came out, which included the Container Runtime Interface, the CRI. And there's that word again, runtime. So what exactly is the Container Runtime Interface? That CRI is a level of abstraction that allowed the Kubernetes kubelet to support alternative low-level container runtimes. The Docker, the company, also a member of the CNCF, and well on their way to breaking up that huge tech stack we know as Docker, contributed their CRA-compatible runtime called Containerd. Containerd was developed in order to integrate Runc into Docker version 1.11. All right, congratulations. You made it through that history lesson. I know that was a lot of information, and you might have even more questions now, but you have some description of a lot of those keywords, a lot of the main projects that you hear about in the ecosystem. Hopefully, you won't be so bogged down with all of that new project information when you begin on your Docker journey. So Docker does all of these things in this list, and it does it well enough that its popularity is unmatched here. Note that when you hear of talk of container runtimes or image formats, what's being discussed is a small piece of that whole package, that entire tech stack, which is described here. The ability to define a container, building an image of a container, managing those images, distributing and sharing those images, creating a container environment, and the concern of launching and actually running a container on your machine. And then, of course, managing the life cycle of those container instances. Let's talk a little bit more about container runtimes. This can be really confusing for someone new to the world of containers. The Docker tech stack obviously contains a lot more than just the runtime. Docker did quite a bit of reorganizing their code base over the last several years, developing abstractions and pulling out discrete functionality. One of the results of this effort was a project called Runc, which I mentioned before, which was contributed to the OCI. This was the first and for some time the only implementation of a low-level container runtime that implemented the OCI runtime specification. There are other runtimes out there, and as of this writing, this is a very active space, so be sure to reference the current list that is maintained by the OCI for the most up-to-date information, and I can provide you those links. I actually have some links at the end of this slide deck that will help you get there. Other notable low-level runtime projects include CRUN, an implementation in C that was led by Red Hat, and Railcar, an implementation in Rust, which was led by Oracle. That project is now archived, but it's interesting. Developing a specification is really challenging, and collaboration on the OCI runtime specification wasn't any less challenging. Figuring out where those boundaries are, what should and what should not be included in the spec, took some time before the release of version 1.0. It is very clear, however, just implementing that specification isn't enough to drive adoption of an implementation. Additional features are needed to make a low-level runtime usable for developers, since we're concerned with much more than just the creation and running of a container. This leads us to higher-level runtimes like Containerd and Cryo. These runtimes include solutions for many of the other concerns around container orchestration, including image management and distribution. Both of these runtimes implement the CRI, which eases that path to a Kubernetes deployment. Both of them delegate low-level container activities to the OCI-compliant low-level runtimes like Runc. That brings me to a point, a question that I get a lot. This here is a link to a really good blog. In short, Kubernetes is deprecating the Docker runtime. And that caused a lot of panic, really because I think most people don't understand what that actually means. In short, that deprecation of Docker runtime support does not in any way, shape, or form mean that Docker is going anywhere or losing support in other ways. You can still use Docker to develop and produce Docker images and containers as you do now. Basically, what happened is Docker was originally, the Docker runtime was originally the original implementation of CRI compliance, but it was through a specific component called the Docker shim. That basically Kubernetes wanted to get rid of that. It was a customization that wasn't necessary for any of the other runtimes. Plus, when Docker hit version 1.11, they started using Containerd, which is CRI compliant. So it really doesn't make any sense for Kubernetes to support the entire Docker tech stack anymore in order to support that Docker runtime. All right, we're getting to the end here. Now we get into just some simple terminology of containers. What is a container exactly? It's a running instance on your machine. What is a container image? That's an immutable executable binary used to create a container. This is usually a made by a Docker file, which is a text file that is a set of instructions that is used to build that image. An image tag indicates the version of the image. Excuse me. A container registry is a library of container repositories and images. And the most popular example is Docker Hub. That is the default central storage for Docker images. And an image repository that stores all of the versions and tags of an image. So generally, that's the image name. All right, what now? You have all of this information. You've got some terminology behind you. Now it's time to just download Docker Desktop. Back when I first downloaded this application, excuse me, I've got a frog in my throat. I work for JFrog, and that's what happens. Anyway, back when I first downloaded Docker Desktop, it was simple. It was easy to work with. But when I look at it today, so many improvements have been made around the UI. You don't even have to use command line commands to look at your images or look at the info behind them. Any of that. You can do that all through the UI now. It's pretty cool. The documentation at docker.com it's very, very good. They have a whole getting started section, which is definitely worth working through. The CNCF website is here. You can find a lot of information about how to get involved in those organizations. It's really important that companies and organizations get involved in these so that we move in the right direction for future components, future development around cloud native technologies. And then, of course, opencontainers.org. This is where you can find all of the links to all of the specifications that I talked about earlier. The runtime specification includes a reference to like all of the current implementations that are available right now. And if you go there, you can find not only the current low-level container runtimes, but you can also find work that's being done in VMs as well. All right, I am ready for some questions if you have any. I think we have a couple minutes before we start with our next speaker. So I don't know if anything came up. I'm going to take another drink.
I was just going to say, Melissa.
My throat.
Yeah, there's we have frogs, but I mean, we never have. But this is taking it to the extreme. I love it. Let me ask you, Melissa. Would you prefer to answer some questions, to go onto the YouTube channel and take some questions there in the chat? There you can drink as much water as you want, and
I'm putting in a cough drop right now.
We'll do that.
I would like to answer this question that's up here for sure.
Sure, absolutely, please do.
Okay, what does it mean by being an application being container aware? As is a container is subset OS, which can run application in isolation. Okay, so mainly what I mean is for Java applications specifically, the way the JVM handled resources. For example, when you launch a container, you can tell that container only use this much of memory on the host, only use this much of processing power on the host. But for a Java application for older versions, it ignored that. It wasn't using, it was getting the wrong number, basically. So you could launch a bunch of containers on an OS, and then they could all stomp on each other because they're all taking resources from each other. So that's what I meant by container aware. There wasn't good enough isolation there.
Thank you. That's awesome. Also, there was a Git repo you were talking about. Somebody actually wanted to know if you could share the Git repo information.
A Git repo.
Yeah, I think it was near the beginning of the talk. Maybe you made reference to one.
I may have. Let me go find it.
Okay.
It might be the Open Containers.